Good day, welcome. Today we will do trigonometry and we will look at double angles. Specifically for this video, I will be looking at the DBE 2018, the supplementary examination. I'm going to dissect the following two questions. So this is working without a calculator. So we look at the information given to us in 5.1. If cos 2 times an angle is equal to negative 5 over 6, where 2 theta is an element of 180 and 270 degrees. First things first, what does cos 2 theta being equal to negative 5 over 6 mean to me? And what does it mean when it says it's an element of 180 and 270 degrees? When I draw my sketch is of such a nature that it shows that the angle is between 180 and 270 degrees. There's my angle 2 theta. Second thing, cos is an x value over a r value. X value being negative 5, my r value being my radius or my ray, which is 6. So I need to calculate the corresponding y value. Now, if I construct my right angle triangle, I can use Pythagoras to calculate the length of this line over here, because the distance here is known to us. The distance here is known to us, so we can calculate this distance. So, y squared is equal to r squared minus x squared. That gives us the square root, positive or negative square root of 11. Now we know that y is in the third quadrant, so that gives me a value for my y to be negative square root 11, because it is a negative distance. It's underneath the line. So the corresponding y value at this point will be negative 11. So negative square root of 11. Now, we were asked to calculate sine of 2 theta. So, the same angle, I must calculate now sine of that angle. So, sine is the opposite side over the hypotenuse. So, the opposite side is negative 11 and my r value is 6. So, sine 2 theta is negative square root of 11 over 6. For the second part of this question, it asks us to give the value of sine square theta. Not sine square 2 theta, sine square of theta. So, let's look at the information that we have here. If I work with double angle and single angle, then I will have to know my identities very well. So in this instance, I need to know all these identities. Needs to be part of my fabric, needs to be part of my toolkit that I have, needs to be part of that. So the one that I'm interested in is where sine square theta will be. So this one tells me cos 2 theta is equal to something, and then I've got sine, so I can try to solve this equation by working with that information. So I say cos 2 theta minus is equal to 1 minus sine square theta. First things first, I want to manipulate this equation that sine square theta is the subject of this equation. I add 2 sine square theta here, I add 2 sine square theta over here, I subtract cos 2 theta here, and I subtract cos 2 theta on this side. That leaves me with 2 sine square theta is equal to 1 minus cos 2 theta. Now, cos 2 theta has got a value of negative 5 over 6. I will now substitute that in the place of cos 2 theta. So then I have sine square theta is equal to 1 minus negative 5 over 6 and divide by 2 on both sides in order to isolate sine square theta. I simplify and I find that 11 over 6 divided by 2. I change the sign to multiplication and I invert my fraction. So 2 inverted becomes a half. So multiply the top, multiply the bottom, because there's nothing to simplify further than that. And my answer is 11 over 12. When I look at the information of the sum, I need to simplify this without the use of the calculator. So first port of call, I need to know my Cartesian plane very well. I must know my quadrants. I must know my angles, 0 degrees, 90 degrees, 180 degrees, 270, 360, negative 90, negative 180, negative 270, negative 360, etc. I must also be very familiar with the cast information where the ratios are positive. The ratios and the co-ratios are positive. So firstly, sine of 180 degrees minus x. So I go 180 degrees minus x, so that is the second quadrant. Sine is positive. Sine of x. Right. Next one. Negative cos of negative x. So negative x will be in the fourth quadrant. Cos is positive in the fourth quadrant, so I say multiply by cos of x. Then there's a plus. Leave my plus there. So I don't want it to be ambiguous when I change signs. So cos of 90 degrees plus x. So here's 90 degrees. Whenever I use 90 and 270, I know a name change must take place. So cos in the second quadrant, 90 plus x, second quadrant is negative. So therefore my name changes to sine, but it is negative sine of x. Then next one is cos of x minus 180. Now remember, we are very familiar with 180 minus x. We are familiar with 180 degrees plus x. But the moment we get to x minus 180 degrees, then we are totally confused. We don't know what to do. So this is two ways that you can look at it. The first one is x will have a positive value and it is smaller than 90 degrees. So I would register x to be in the first quadrant. If I subtract 180 degrees, I'm going to proceed this direction. So I will end up in the third quadrant. So that's one way of looking at it. The other way is we work with rotations. So if I add 360 to this, it will take me to the same place where I was. So x plus 180 is the same as 180 degrees plus x, which still takes me to the third quadrant. And in the third quadrant, cos is negative. So now I have my information. A negative times a negative will give me a positive. So I've got cos x times sine x plus, and then a negative times a negative is a positive, so it is sine x cos x again. So that gives me 2 sine x cos x, which can be reduced to a single ratio of sine 2x. I want to thank you for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Goodbye.